Hey guys, in this video we will be looking at quite a few concepts, namely creating tables using SQL scripts, and also the fact that we can have multiple commands in one file and how we can execute them all versus executing them in parts. Now, the first thing that we want to do, having a new script file and the desire to start adding something to a database, in this case the school DB, is to set the context for our file, meaning set the database that we know we want to be using. And we looked at that before, and the keyword is use, and then we specify the database that we know we want to use. So I say use school DB, end it with a semicolon, and I'm just putting some space in between, and I could just add comments up top, but I'll leave the comments for when I'm saving the file. And then after I specify use DB, then I can go ahead and start filling out the rest of the query file. So please note that SQL commands run in a very linear fashion, meaning order matters. You have to say this before you say anything else, and whatever order you put the things to happen in, that is exactly the order it will be executed in. All right, so the first thing that we want to do is create a table. So to create a table, it's a similar bit of code. We say create the object type, which is table, and then we give it a name. And in this case, I want to create a table called students for my school database. Then I will just open and close brackets and end with a semicolon. So I like to open and close brackets at the same time because that way I don't open and forget to close. All right, so I prefer to do it that way. Also, you'll notice that a command can span multiple lines. A command does not end until it sees a semicolon. So once a semicolon is present, then it knows that it is the end of the command. So even if I take up 20 lines with this command, you will see all of that as one command. So I'm just spacing it out this way so that we can see exactly what we're about to type. Now, the very first thing that we include in any table, at least for me, it's best practice to do it this way, is the ID. Remember, in the beginning of this course, we discussed what you call the primary key, which allows each row to be uniquely identifiable. So in your country, you may have a tax ID, and that allows the authorities to know exactly who you are just by having that tax ID. Well, in our database, we want to have something similar to that for each student. So the simplest way to do this is one, the name ID, which is the name of the column. So the first thing you specify is the column name, and then we say data type. And the data types can be integer, they can be varchar, they can be date. So in other words, they can be numerical, they can be alphanumeric, or just letters or string, so to speak, and they can be date. They have a number, quite a few of data types. When we're writing the script, you have to actually remember the data types, but I will include all of the possible data types in this lecture, and in another video we'll see how MySQL Workbench helps us to keep track of these data types and which one we want to use. But we go ahead and we say ID, and then the data type we want is int, because our ID is now going to be counting each time a record goes in. And think about it, if each time a record goes in, that number goes up by 1, then no two records will ever have the same number, because they will be numbered from 1 to n number of records. So what we do, and you see as a common pattern, is just to specify a column called ID, set it to be an integer, and then you would say something like auto underscore increment. So this means that each time a value goes in, this column will automatically increment, and it's going to start at 1. So the first record will have the value 1, the second record will have the value 2, and for as many records as you have, this number will go up. Even if you delete, say you have 15 records and you delete row number 5, if you add a 16th record, well, at that point it would be the 15th record because you just removed 1. But if you add another record after record 15, then the number will still go to 16. All right, so this number will always increment no matter how many records precede it. So that way it will never have the same number as a preceding record. So we say auto increment, and then what happens is that in specifying the columns that this table should have, we have the name, the data type, and then what we call attributes. All right, so this is the first one. So I'll just complete this. So we have ID, integer value, auto increment, and then I also want it to be the primary key. So I just write primary key. So that's another attribute that I'm giving it. And then if I'm finished with the attributes, I can just press comma and go to the next line. And then the next thing I want for the student is the last name. So that's a column name. I notice color coding is giving me what is a keyword versus what is a column name. All right. And then a last name would be more like a string. It's a word. So we wouldn't have integer. It's not numeric. So the next data type would be, and if you just start typing, you'll see that they're giving you all of the potential values that could be used for data types here. So the most commonly used data types for string-based values are varchar and nvarchar. So at any point, if you know that in this column or any data point associated with this column, you should be storing a word or an alphanumeric sequence, then I suggest that you use an nvarchar or a varchar. So I'll just use nvarchar and I'll set this to 50. So by doing that, I'm setting that this last name column, whatever value goes in, should have no more than 50 characters or 50 spaces or whatever it is that makes up the string that is about to go in here. Should be no more than 50 if I sit down and count the number of letters in this last name. All right. And another attribute that I'm going to add is not null. So this will specify that this last name should never be empty. That's what not null says. So any column that you put not null on will never be empty. So we could have put not null up here, but the fact that we put auto increment means that it's always going to be counting. So it won't have time to ever think about being empty. All right. So it could be placed up here at no harm, but for me, it's just redundant. And I'd rather just separate them so you can appreciate why auto increment works the way it works and not null specifies otherwise for any other column. All right. So another column we want is first name. And notice no spaces should be ever put in the column name. So I just did that out of instinct for my typing, but it's a good thing I did that because then you see that this is giving me an error and it's coding both of these as keywords when they should never be keywords. So if it's a case where you need a space, then you want to use I think that's apostrophe or an accent. And that's not a quotation mark. That's a quotation mark different from the apostrophe. All right. So take note of the difference between the two on the keyboard. So the quotation mark, the single quote is not what we want here. We want the apostrophe. And then that will say anything that is in between these two should be seen as a column name. Now, for me, it's best practice never to use a space. So if it is that you want to not have it as, last name being, crunched together because really and truly they are two words, then I suggest to use an underscore. And then that way you can have a cleaner column name and design going forward. So I'll just add an underscore to last name, first name, and I can just copy these attributes from last name since they are going to be common columns. And note each time I'm going to a new column definition, I end the line with a comma. So ID, data type, all attributes, comma, last name, data type, all attributes, and then comma. And then as long as there's a comma ending, then you'll see that there's an error here. But we're not finished with the table as yet, as we're going to put in date of birth, and I'll just use underscores so that we can see each word specifically. So of course, going forward in your design, you probably have your own pattern and your own style. I'm just making suggestions and best practices as I go along, but ultimately you will develop your own style of doing things. And we would use a date data value for this, and we could say not null. So no student should ever go into the database without a date of birth, a last name, or a first name. That's essentially what all those not nulls mean. And then any student would have been enrolled at some point. So I can say enrollment date. And once again, I'm going to use my underscore. And this should also be a date, but I'm not going to make this not null because maybe you would have signed up, but you haven't enrolled in any courses as yet or whatever. So I'm just showing you that you can specify some columns as not null, meaning they are very much required for any row to be input. And then you have those without the not null. And notice there's no trailing comma at the end of this statement. So that would have created our students table. Now, in addition to the students table, I'll just go ahead and create another table for courses. And pretty much it's a very similar procedure. We just open and close our parentheses, and then we go ahead and fill in all the columns. So once again, ID, a unique identifier or primary key for me is best practice. Always have one on your tables. And in this one, I use the pattern where I just said ID. Sometimes you'll see people actually specify the table name and the word ID and write it out. So you'll see it like that sometimes. But once again, it's all a matter of personal style and preference. So I'm going to leave it like this so you can see the two ways. And then each course should also have a title. So remember that a table is a collection of data points. So right now we're actually defining all of those data points that would create factual information about whatever entity it is that this table will be storing those facts on. So courses, what is it that a course has? A course has an ID, a course has a title, which is an varchar of type. Maybe I can put this to 100. Maybe the course name is long, and a course can't exist without a title. So I'm setting the attribute to be not null, meaning no course can ever go into the table without having this value. I'm going to set the number of credits, and I'm making this an integer value. And just for fun and for demonstrative purposes, I won't make that not null because maybe we have thought of a course, but we haven't thought of how many credits we're going to give it just yet. So I'm not setting that as not null. But then we have course code, which is also in varchar, and I'm going to make this a smaller value because generally speaking, a course code is not more than 5 characters. But then of course, according to your needs, you set the size that you want. And I'm also going to say not null because it doesn't make sense to create a course that doesn't have a course code. So, and I'll just add a comment here so you can see what I mean. So a course code could be like, maybe this course in a university would be coded CS201, Introduction to Databases, right? So that's an example. So you see a comment can be included here. Once again, a comment will be ignored by the execution sequence. The blue dots on each of these command lines or command blocks, rather, specify that this is a command by itself. Of course, we could have written all of this in one line, so there's no harm in writing it in one line, but then I just broke it out so that we didn't have to scroll across the page to see what was happening, right? So, and then you see here, it's harder to add this comment because then the comment is including some code in it and causing an error. So that is one of the reasons that I would have broken it line by line so that we could see each line and scrutinize it individually. All right, so you see I have added some files here, some comments here, sorry, and that's just for informational purposes. When you're reviewing this code file, you can see exactly what is happening here and be guided accordingly. Now to execute, once again, we can just click our lightning bolt, which will then execute use school.db and then this in the order that it is set up in the document. But then if I only wanted to execute a part of the query, I could just highlight it and click this lightning bolt with the cursor. And if we just hover over it, we see that it executes the statement that is under the keyboard cursor or has been selected. So essentially that's what that means. So those are two ways. So if you have multiple commands in one document, but you're only executing one or few of these commands, then you can just highlight that command or those commands and you just click that one with the cursor. So I'm going to just execute all of these, which will then choose the database and then create everything else. And then I'm getting a warning here. It's saying that I have some character reference stuff. I think that might be caused by the versioning. Let me see if anything happened. So my tables were created. So you see we have a success, we have error, and we have warnings. So sometimes you get warnings, and most times these warnings will be because you might be using a certain bit of code without specifying certain things. Most times warnings are harmless, but in this case it is because we got our table with all the columns and we can just drill down and see everything about our columns accordingly. And if we take a look at our columns, so we drill down into SchoolDB tables, courses, and click columns, then below the schema section, then we'll see definition. So we have course ID, and you notice that it kind of stands out. And if you look at its attributes, they're telling you that it's an integer, it's auto-incrementing, and it is the primary key. So MySQL uses those little things, AI and PK, just to show you the attributes that it has been given. All right. And then you'll see all the others with their attributes. This is title is varchar 100 and so on. So that is essentially how you go about creating tables in MySQL using commands. And I'm just going to save this file and I'm just going to say create tables. And we're saving that as an SQL file. And I'm going to be sharing that with this video. Now, another way we can actually create tables without the use of the SQL script is by using the GUI tools afforded to us by MySQL Workbench. And we can do that by right-clicking on tables. So having gone down into the database and we have the tables part exposed, we can right-click that and then we say create table, which will then launch a new interface allowing us to specify the name. So another table that would be useful in a SchoolDB would be a table to store the lecturers, right? So we are tracking the courses, we're tracking the students, and now we need to track the lecturers. So I'm just going to call this table lecturers, all right? And the schema, once again, is SchoolDB. We can leave that, all of those things can be left alone, and then we can go ahead and specify the column name. Now, it's worthy to note that MySQL supports both relational database style and what we call no SQL style, which is a variation of databases that doesn't rely on relationships. And to get that, you would use MyISAM. But then if you click on this engine dropdown, you see that there are quite a few storage or engine styles that MySQL is capable of. To be honest, I always use InnoDB because in a relational database setting, that is the one that we want to use. So we can leave that alone, and then we just go ahead and specify our column name. So we got a primary key column by default because MySQL is forcing us to practice what is best. So I can always change this column name and I can say lecturer ID or just ID. I'll just say ID. The data type is already int and they're already telling me that this is a primary key. If I untick that, you'll notice that the emblem changes. So I'll just retick it. NN means not null, and each of these columns means something different. So the checkboxes mean something. You can always just hover over the letter or letters to see exactly what is being described. All right. And the one that I'm really interested in is auto increment. So remember that when we were creating our tables here, we specified primary key, which is PK over here, and we also specified auto increment, which is AI. So I'll just tick AI. All right. And from this view, we can actually add more data. So we could add a default value. We don't need a default value for our ID because we should never have a default value for our ID. We can add comments so that we know in the future, or if we have to share this database with anybody, we can always write comments so that they can see exactly what this column is for. And if you tick it here, then you'll see that it is ticked down in this section also. So you can use either one of these to manage those attributes. Okay. And then to create another column, we just click in the next line, and then we say first, or let's use the same convention, last underscore name. And then this is using the data value type varchar as opposed to nvarchar, which we used, but I'll just leave it as varchar. And then I can just tick not null. And I'm using first underscore name and also not null. And something else about a lecturer would be, let's say, title. So maybe the person is doctor, or let's say degree. So is it that they have a BSc, a MSc, or a PhD? All right. And then we can leave that one as nullable. So you see that the emblem changes based on certain attributes being selected. All right. You may get a different color or visual cue to the left-hand side of the columns. And then once you've finished creating all of your columns that you intend to have, then you can go ahead and click apply, which will then give you a very similar looking script to what we just penned. But then you see that there are certain variations. So that just goes to show you that there are more than one ways that we could have actually written this script, because here ID is being specified, but then primary key is down here as opposed to where it was in one line when we did it. So you see that there are different ways to write it. Also, for the nullable fields, we didn't write the word null. We just left it blank, and it automatically assumed that this should be null. So if it's generated, it's going to look a bit different from what we have. It also specifies the engine here. So if we click apply, then it will let us know if it was executed successfully or not. And when we finish, we can look over to our table listing and we will see our newly created table there. And if we look at the columns, then we'll see that everything looks in order. So that is how you can go about creating a database table using the MySQL Workbench interface.